Ever wondered why armature winding is crucial in DC machines? This winding plays a pivotal role in the energy conversion process. It's the main current-carrying conduit where the load current flows. It's also where the electromotive force or voltage is induced. In essence, armature winding is like the heart of the DC machine, pulsating with electricity, converting energy, and driving the machine's operation. Without armature winding, a DC machine simply cannot function effectively. How does armature winding work, you ask? It's a fascinating process. Let's start from the very beginning. Armature winding is all about wrapping wire around an armature to create a magnetic field. Now, what's an armature, you might wonder? Well, it's a component typically made of iron, which is an excellent conductor of magnetic fields. This iron core is where the winding magic happens. So imagine this iron core sitting ready for its transformation. What comes next is a meticulous process of winding wire around it. The type of wire used is usually copper, known for its excellent electrical conductivity. This wire is carefully wound around the armature, creating what we call the armature coil. Now, here's where it gets even more interesting. The winding process isn't random. Oh no, it's far from it. The wire is wound in a very specific way, with a clear purpose in mind: to make sure the magnetic field produced by the armature interacts with the magnetic field of another component. This could be a permanent magnet, or in the case of electromagnets, it's called a field winding. This interaction between magnetic fields is the heart of how motors and generators work. It's the dance of the magnetic fields, if you will, that converts electrical energy into mechanical energy, or vice versa. The winding process is a craft that involves a keen understanding of electromagnetic principles. It requires precision and it demands patience. After all, a single error in winding can result in a faulty armature that could bring the entire machine to a grinding halt. So, the next time you look at a motor or a generator, remember this. Inside that machine is an armature wound with wire, creating a magnetic field. It's a work of engineering art that, in many ways, powers our world. So you see, the process of armature winding is intricate and requires precision. It is a craft that transforms a simple piece of wire into a powerful magnetic field. Let's dive deeper into the step-by-step process of armature winding. It's an intricate process that demands precision, patience, and a firm understanding of electrical principles. Our journey begins with the preparation of the armature core. This core, often made of iron, is the heart of the armature, providing a path for the magnetic field. It's crucial to ensure that the core is clean and free from any defects that could interfere with the magnetic field. Next, we move on to the winding of the wire around the core. This is the phase where the magic happens. The wire, or conductor, is wound in loops around the armature core in a specific pattern. This pattern is critical to the performance of the machine. It's not just about wrapping wire around a core, it's about creating a path for the magnetic field to follow. Now, where does this wire go? The ends of the wire are connected to the commutator segments. This is a key step, as the commutator acts as a bridge, allowing the current to flow from the armature to the external circuit and back. Once the winding is completed, the armature is carefully placed inside the stator. The stator, which houses the field winding or permanent magnet, interacts with the magnetic field produced by the armature. The alignment between the stator and the armature must be precise, as this interaction is what generates the rotation. But let's not forget, the winding process needs to be done meticulously. The magnetic field produced by the armature winding must be strong enough to interact with the field winding or the permanent magnet. A single misstep could lead to a weaker magnetic field, reducing the efficiency of the machine. So we see that armature winding is a process steeped in precision, intricacy, and a deep understanding of how magnetic fields interact. It's not just a mechanical task, but a symphony of electrical and magnetic principles working in harmony. And that, in a nutshell, is the step-by-step process of armature winding in DC machines. So, what are the key points we've learned today about armature winding? Armature winding is crucial in DC machines. It's not just a process, it's a craft that determines the effectiveness of the machine. We've delved into the winding process, showing that each step is pivotal to the overall function. Without proper winding, the machine simply won't operate as it should. It's a fascinating blend of science and craftsmanship. Remember, armature winding is not just a process, it's a craft that powers DC machines.